Hello everyone. We are going to have a discussion on chapter 1, which is entitled Functions and Mathematical Models, and we are going to tackle functions algebraically, numerically, graphically, and verbally. I divided the lecture into two, so in this discussion we are going to delve on function as defined algebraically by numbers and graphically. And the second part of this lecture will be on this verbally or by words. So what is a function? Well, many beginners in algebra always ask the same question. And when I was also a beginner in algebra, I used to ask the same question. Now, a function is defined as a relationship. So this is a relationship. But what kind of relationship is it? Now, in the example, I'm going to give you an example which will show this relationship. It's a relationship. So we have a coffee here and we have a timer. Now, for example, you are given a cup of coffee, or you just poured a cup of coffee instead. And since you are a beginner in algebra, you want to test the relationship between the coffee cooling, let's say temperature, degrees Celsius, which stands for the cooling of the coffee from the time it was served at t is equal to 0 to a certain point in time. So a certain t final. And of course, we are also going to observe the timing. Let's say this is t, and this is in terms of minutes. Now, practically, when you are served a cup of coffee, or when you just poured when you just poured boiling water on your cup of coffee, at first at 0 minute, which in this case is here, at 0 minute, your coffee temperature would most likely be somehow lower than the boiling temperature, of course, because you just poured it, and in pouring it lost some energy. So let's say at 0 degrees Celsius, or I'm sorry, if at 0 minute you have 90 degrees Celsius, and that's at 0 minute. So as you can see, there is a relationship between the passing of the time from 0 minute onwards and the temperature of the coffee from 90 degrees Celsius down, meaning it cools, right? So there is a certain point in time where it will reach about room temperature. What is our room temperature? Our room temperature is equal to 20 degrees Celsius. So there will be a certain time wherein your coffee temperature will try to reach 20 degrees Celsius. But in this example, I'm going to describe to you that no matter what you do with the coffee, no matter how long time passes by, you know, this cool temperature will not be reaching 20 degrees Celsius. So before that, we are going to describe first the relationship between the coffee and the time that passes by. So number one, what is the relationship First, it is 1 to 1. Meaning, what does 1 to 1 mean? For a given time, okay, for a given time, there will always be a corresponding temperature T. Now, for you to be able to understand that well, let us just express your temperature in minutes. Your time in minutes as x, and your temperature as y, because x and y letters are mostly used in algebra. So again, let us say your minutes would be x and your temperature would be y. So as you can see in your mind, just think about it. For every passing minute, at t is equal to 0, you will have a corresponding, I'm sorry, that's not t now, we already changed it to x. So minutes and temperature degrees Celsius, this would be x. This would be x and this would be y. So at every passing minutes, for example, it's 0, there will be a corresponding value for y, or for the degrees Celsius. And for example, let us say 1, so it will cool a bit at 80 degrees Celsius, and so on and so forth. And if you are going to strictly observe the patterns, if you strictly observe it at 1 minute, the coffee temperature cools down very rapidly than when it reaches at a certain time of, let us say, 20 minutes. Now this is a very long time already, and our coffee temperature might have just reached, let us say, about 20.8 degrees Celsius. And further than 20 minutes, let's say 25 minutes, it will reach around 20.2 degrees Celsius. So the relationship between your x and between your y defines that for every passing time, you will have a definite temperature which is defined by your y. Okay. Now, as we have stated earlier, we have a defining relationship between your coffee temperature and the minute or the time that passes by. So as I've told you, we're going to let x as your value for the time that passes, and for your y would be the value of the temperature according to the time that passes. So I'm going to show you with a table what the observation for the cooling of the coffee is against the time, which is in minutes. So let's start, for example, at 0 minute. That's too thick. Okay. Let's see at 0 minute. Remember, this x is in minute and this y is in degrees Celsius. So at 0 minute, you will have 90 degrees. Now at a certain time interval, let us say 5 minutes has already passed. So we are going to get the temperature of the coffee in 5 minutes. After 5 minutes, the temperature of the coffee would be 42.9 degrees. Now in another 10 minutes, we are observing at an interval of 5 minutes. We will have a temperature of 27.5 degrees Celsius. In another 5 minutes, let's say we already have 15 minutes now, our coffee temperature would be 22.5 degrees. And in another 5 minutes, that's 20 minutes from now, we will have 20.8 degrees Celsius. Now taking this to extended x and y values, let's say we have after 5 minutes, this will become like 20.4 etc. degrees Celsius. Now after 30 minutes, this will become 20 let's say 0.1 degrees Celsius. Further going to the time will only lead us to a value which is closer than 20 degrees Celsius, but wouldn't equal to 20 degrees Celsius, because 20 degrees Celsius is the room temperature. It's the room temperature. And according to thermal conductivity theory, which is in science, and you can look it up also as your research, thermal conductivity, energy is just passed from one object to another. So in this case, our coffee temperature and the surroundings don't have equal. The coffee temperature and the surroundings are not equal are not in equilibrium. So for you to be able to understand this well, you also could look up to this scientific concept, thermal conductivity. So that explains why further going to the time after 20 minutes wouldn't lead us to an equivalence of 20 degrees Celsius for the coffee temperature. So now we're not going to focus on that, of course. We are going to focus on some terms here. Now this point here, or this part of the table here, is number 1. These are your x values. And your x values are what we call the independent. Independent, it's wrong spelling. So independent values. And they are called the domain of this relationship. The domain of this relationship, the domain of this function. This is 1 to 1, as I've already explained in the previous slide. Now the part here will be, okay, this part here will be your set of y values, and they are often related to the dependent values. And in this case, this would be your range, or the value of your range. So remember these 3 ideas here. Your y values are your dependent values. At the same time, they are the range of a certain relationship or a certain function given. And your x values are your independent values, and they are the domain of a certain given function or a certain given relationship.